morning, everybody. Welcome to Crop TV. I'm Charlie Herberg. I'm a professor of agricultural engineering and the manager of the Grain Quality Initiative. Today, I'm going to talk a little bit about the quality of Iowa corn and soybeans as affected by the two issues that we had during the growing season, the drought and then the major storm that we had later on. As far as an outline for what I'm going to talk about today, I always like to start discussions with a little bit of history as to how we got here, and sometimes the history is after the fact, but it still is useful to understand how we got here, and a little bit about growing production and storage statistics in Iowa, because that sets the stage for whether or not we have a storage issue or not, or don't. Then I will talk about the drought and the derecho storm, and then why, frankly, we didn't have some of the things that many of us thought we might during harvest season, and then going forward, where are we in grain handling and management for 2021? By way of history, and this chart is a little bit busy, but it's an after the fact chart, but this chart shows the various progress elements of the 2020 crop, this is corn, over time. And the big point that I want to make here is that if you look at the planting progress in the top one, we had one of the earliest, if not the earliest, planting seasons ever in 2020. And in fact, a lot of us were thinking that we were looking at some very good crops with some very relatively early harvest and very high quality. That's the way it was starting to shake out in May and June. However, if you look at the second chart, you notice that the green areas get smaller and the lighter green and yellow areas get bigger. That's the percentage of good to excellent crops over the season, and you'll notice that fell somewhat towards the end of the growing season. The red bar in there is August 10th, and for those of you that weren't around at that time or weren't in Iowa at that time, that's when we had the derecho storm that marched across Iowa and was the largest thunderstorm I think that the National Weather Service ever had on record. The bottom graph are the various stages of growth of the crop during the season, and the point to be made here is that the solid line in each one of those, the solid line is 2020, and then the various types of dashed lines are other years. And the 2020 line, from planting through emergence and dent and dough and maturity, the solid line is always to the leftmost of all the others. In other words, the early planting translated into earlier of all the other stages of crop development through the season. Basically, that distance maintained itself. This has turned out to be more important than we thought when evaluating the impact of that August 10th storm. Soybean story is pretty much the same way. We had early planting, and everything was early. All the various development stages were early, and on August 10th, we were farther ahead toward maturity than just about in most any other year we've had. But the storm and the drought, which peaked more or less at the end of the growing season, definitely reduced the amount of good and excellent crops, particularly mid-August and later. That translated, in Iowa at least, that translated into lower yields for sure. We noticed that the last crop production report in January took 3 bushels off of the corn yield in the United States and about that same amount off of the corn yield in Iowa. So we were definitely down from the previous year in yields, both nationally and as a state. Total production, however, was still greater in 2020 than it was in 2019. That's because of acres and more acres. But the point to be made here is that while we had these issues, this was not exactly a low production year. Lower than we thought in June. Many of us were thinking that in June, these numbers for Iowa and the United States in both corn and soybeans would be records, 15 billion bushels of corn and maybe chasing 3 in Iowa. So we were looking for some very significant crops, but nonetheless, they weren't shortage type crops. Just that the end of the growing season took some of the luster off, and as we'll see in a minute, the end of the growing season is where quality is determined, even quite toward the end of the growing season. I like to look at, from a crop storage perspective, like to look at the production and the carryover to make an evaluation of whether we will have storage issues. That is, storage issues means the total of production and the crop on hand, the total of those two numbers, is larger than our storage volume, which is about 3.1 billion bushels according to the USDA. And if that becomes a positive number, that balance number, this means that a certain amount of grain will be looking for a home and will probably find it in an outdoor pile temporarily. Outdoor piles are always a challenge for maintaining grain quality. Well, you can see that in 2019, we had a surplus and we had outdoor piles. Maybe less than some previous years, but still we had outdoor piles. Whereas in 2020, that was basically a balance. So we didn't have outdoor, or at least significant amounts of them, outdoor piles looking for cover this past fall. And that number then was borne out by the USDA's numbers for crop in storage in December. That's right after harvest. After harvest, USDA last year estimated that there was 4 billion bushels of corn in storage in Iowa in December, whereas that's a little bit more than production. So you see it's a carryover situation. Whereas this year, the estimate is 2.4, pretty much a balance with the amount of storage and the production, and therefore our anticipated carryovers in Iowa are going down and the storage problems are becoming fewer. We have to remember that Iowa, by virtue of ethanol and feed, we use about 200 million bushels a month. So that balance number, if you divide that by 0.2, you get an estimate of how many months before we can get all the grain picked up and put in decent storage. This year, we didn't have a problem at all. The previous year, we had outdoor piled grain into probably December or January, waiting for it to be used. So the net result was that we did not have a storage crunch, which is probably a pretty good idea. It was a pretty good occurrence considering the harvest weather challenges. We had a drought. This is the National Drought Monitor as of Labor Day, basically, just after Labor Day. And about 39% of Iowa's area was under the top two of the drought categories, 2 and 3. There is a fourth one, with categories 2 and 3. And category 3, the red, was close to 15% of acres in some pretty strong grain growing areas in southwest and west central Iowa. For comparison, the last drought year we had of significance was in was in 2012. And many of you may remember 2012, where we had some marketing and toxin issues, particularly in southwest Iowa. Notice the coverage of the drought in 2012 was larger than this year, than this past year. The drought was not as severe. There was not as much area in the top category as there was this year. And in fact, in 2012, there was a sliver up in northwest Iowa that broke the fourth extreme category. So we had some prediction, we had some data from the previous year to previous drought year to get an idea of what might happen. What might this drought do to the grain quality patterns of the year? This were basically our conclusions from 2012. Yield, of course, is lower. We all know that with the presence of drought, shortage of water. But in a drought year, test weight is often higher, and it was that year. That's because seeds are small, they pack tighter, and as a result, the apparent test weight is high. They also have a chance to more or less fill out normally. With a dry year, it accumulates over time and the plant shuts down over time. So it has a chance to more or less fill the best it can towards the end of the growing season. Protein was higher. Starch is obviously lower. Protein is higher. But protein was higher, and that meant the feed value was not too bad. We did have aflatoxin issues. Aflatoxin is a poisonous byproduct of a particular type of mold that likes drought conditions. Southwest Iowa, and to some extent South Central, had instances of aflatoxin be above 20 parts per billion, and as a result created some marketing issues for human food and for animals that are particularly sensitive, such as poultry and swine. On the soybean side, protein in a dry year with less resources at the end of the growing season, protein is always lower and oil is always higher. How that translates into value kind of depends on the processor and their market. Beef cattle and to some extent swine can be blended around, and the increased oil yield offsets the protein. If the processor is selling into a very protein-sensitive market, then the oil yield wouldn't necessarily offset the lower protein. But we expected that this year the proteins would be low and the oils would be more or less the same amount high. So we had expectations for the drought. We had no expectations for the storm situation because we haven't really had storms like this. The closest thing I can remember is the hailstorm, ironically on the same date, August 10th, in 2009, that traveled across Highway 175 and tore up a lot of cornfields. But even there, the coverage level wasn't so high. The storm tracked clear across the state. That's some 13 million acres between the red bars, where the satellite radar indicated that the storm had impact. Some of it was already drought area, others were not. The peak of the storm was in east central Iowa, Cedar Rapids, and right from Ames to Cedar Rapids and a little bit farther. That's where we had 80 to 140 plus mile an hour winds for a sustained period of time on August 10th. That's quite early to have the corn killed, and that's one of the characteristics of a storm as opposed to the drought. The corn basically was stressed immediately, instantaneous, sort of like an early frost. It was instantaneously knocked down. These pictures are basically Megan Anderson's grading of the damage. 1 is flat, 2 is tangled up and not quite flat, but still pretty well messed up, and 3 is just leaning. The text below were the expectations that we had at the time for what would happen. That is, if we cut the maturity off right then, what would happen? And most of us felt that with the Category 1, we were going to get very low test weights being a measure of cornfield. We were going to get very low test weights, and therefore probably low maturity, lots of field mold, difficult storage, etc., and progressively better for the twisted and the leaning corn. Those were the crops team's kind of guesses as to what we would be looking at. We'll get to what actually happened in a little bit, and some of the reasons behind it. Again, Megan had a chance to take an aerial tour, and this is a field that had been flattened. It was pretty clear from the aerial photographs which fields got flattened and which did not. We also lost storage capacity. The best estimates we have is that we lost about 60 million bushels of commercial corn storage or storage in general, and about the same amount of on-farm grain bins and so forth. With these numbers, we really didn't expect to create a storage crunch, because with the reduced yields, basically we lost more yield out of this than we did storage. So in general, other than having to move grain around from facilities, the picture on the left there is the facility at Luther, Iowa, and it took it on the chin and was not really very operational during harvest. So there was a certain amount of moving grain around to get it to places, but overall in total storage terms, we probably did not lose as much storage as we did yield. Well, as I said, remember, we thought we were going to have a real quality problem. Quality problems like that really create crop insurance complications. Obviously, the flattened corn and the lean corn was subject to crop insurance adjustment, but to complicate that with quality loss would have been a very difficult situation. Quality has to be adjusted before harvest, before the grain is put into a bin, and if you look back at those fields, you could probably see what the problems would be in getting good samples and coming to an agreement on what the value of the quality loss, as opposed to just the percentage of flattened crop and therefore reduced production having to do with just the physical damage. Well, this, as we did in 2012 when there was an aflatoxin potential from the drought, the Department of Ag collected a set of samples, 4 per county as a matter of fact, and we worked with them to do quality testing as well as the toxin testing on those samples to get an idea of where and how much the quality was deteriorated by the drought, and then in this case by the storm or by the drought plus the storm. Basically the drought in the storm areas made the corn fall over more, and so I think that was probably the basic point for where there was an overlap of the drought hazard and the storm. I took protein and test weight as 2 significant measures of value. Normally we would expect that test weight would fall from the storm, and it would be okay in the drought areas, and the protein would probably fall and would be okay in the drought areas. Overall, there was nothing really striking about the difference in test weight and protein from what you might call a normal year. Protein has been going down for some while in corn as a result of increased yield, so 7% protein was not that unusual, and certainly the test weight numbers on average were not remarkable at all. They were 57.5 as an average. You would say that's a pretty decent average yield or average number for 400 samples taken across the whole state. And we broke that down into crop reporting districts. I hope you can see this well enough. The blue ones are the ones that were primarily affected by the storm. The tan ones are the ones that were primarily affected by the drought. And it was more or less what we expected. The test weights were highest in the droughted area where it wasn't confounded with the storm, and the protein contents were highest in those areas, and vice versa. The test weights were the lowest. Well, they weren't low, but they were the lowest in the storm damaged areas. Part of this is probably due to the flattened fields being taken out by the crop insurance. That was a good thing, to take out those fields and zero them out. If any of you had an opportunity to watch harvest operations on flattened fields, you would soon get an understanding of how difficult that is and how hard that is on machinery. We zeroed out quite a number of fields, and that was a good thing from all the way around to take that product off the market. But you can see here, one of the things that I want to note is that the moisture was quite low for harvest moistures. These samples were taken of inbound grain at grain elevators, and they were 14, and I imagine some of you had experiences with grain in the 12s or 13s for corn. Soybeans probably in the 10 to 12 range. That's not necessarily what we try to shoot for, because there's weight lost in the moisture not sold, but at the same time, that really gave us a break on the corn quality. We were expecting to have a lot of mycotoxins, particularly in the droughted grain, aflatoxin, and in the flattened grain, vomitoxin, which is normally a cool, wet type of fungus or type of toxin that we'd see in the grain laying on the ground. All of the samples, there were actually relatively few samples that had any kinds of high levels as compared. If you go down to the bottom there, the numbers along the bottom in parts per billion are the general guidelines for feeding, and in the case of aflatoxin, it's the FDA regulatory limit. We just didn't get there. Basically, we did not come near at all to the guidelines or the regulatory limits with just about any of these toxins, and the drought areas did not really show up high aflatoxin as we expected. There was a little bit more of the vomitoxin in the blue areas, the storm areas, but not particularly extreme as we might have expected with that situation. And that bore out here. We sorted out samples, and the ones that had drought stress, we picked them together to see if that told us a different story, and it didn't. The aflatoxin levels were not high, and neither were the vomitoxin levels. So the conclusion here is that we didn't get the mold and deterioration in the field. Both of these toxins would be produced in the field after maturity. We didn't get the levels that we thought we were going to get, and I'll explain that in just a second. But had we, it would have made the crop insurance process and the marketing process a lot more complicated than it turned out. We went out with the help of the crops extension specialists. These are the pictures on the bottom are the same ones that Megan took earlier. We went out and actually hunted up fields that we thought fell in those three categories to see if we could deliberately find some really bad stuff, low test weight or low protein. And it was just hard to do. The grain had dried very rapidly after the storm. Even the grain on the ground dried out very rapidly, and I'll show you the weather conditions in a minute that led to that. But even even corn harvested from those fields, fields like what are shown in the picture, did not show particularly low test weights or abnormally low protein contents. So we had basically in the drought area what we expected: higher test weights and higher proteins, but very few toxins in the drought area. In the storm area, if we sorted it out, we had a little bit lower protein and a little bit lower test weight, but nothing remarkable. Soybeans basically showed what soybeans usually do when you shorten their growing season. They show you low protein and quite high oil, and we have that. That's going to mean that soybean meal and distillers grains will probably be a little low in protein if you're feeding this year. Expect a little lower protein, but otherwise not serious from a mold perspective. I said I would show you why. This is temperature and relative humidity, and the blue line, I believe, no, the tan line is relative humidity. There was a spike, but for the most part, the relative humidities were around 50, and in the middle of the day, lower than that in September, and relatively warm temperatures. That persisted into October, clear towards the end of October, actually, when then we started to get a more fall-like pattern with higher relative humidities. All of that added together to incredibly rapid dry down. If you remember the period around Labor Day, we had 90 degrees for peak temperatures and extremely low humidity. I imagine we were losing 3 to 5 percentage points of moisture out of the crop per day during that period, and as a result, that was exactly what we needed for all the grain that had been under stress. Take it down through the dry down period as quickly as possible. That's when grain gets field fungi, when it sits from 30% or so corn down to 18 in the field, drying slowly. That's when we get mold problems in the field. It was not drying slowly. Dryers would hardly dry as fast as what we saw this past fall. So we ended up with some extremely low moistures over in the tan side of life there in terms of what the moisture contents the corn would come to. And that helped us a lot from a spoilage perspective. It did, however, create some stress from the standpoint of marketing, and there's not much we can do about it. But the numbers down in the lower right indicate kind of what we can lose per acre and per bushel by losing moisture content. Undoubtedly, this over-dry grain has shown up in a way in the crop production estimates, because we're now getting to the point where the crop production estimates don't represent field sampling, they represent actual material in storage. And if the material in storage is 12%, it's 3 percentage points less in weight than a normal year at around 15. So we paid the price in some overly dry grain and some brittle grain that breaks for the protection we got against mold and other problems caused by the two extreme weather events. Soybeans showed the same thing. It's very easy when you have relative humidities in the 40s and 50s to get soybean moistures below 10. Well, the table in the lower right indicates that we could get a dime or more per bushel loss for every point of moisture that we lose, and we have some very dry soybeans. We also get more splits and breakage, but that was again sort of the price you pay for getting the moisture out in a what could have been a problem year. Here are some of the impacts of over dry grain. Recognize that the lower yields will, to some extent, ripple through, or the lower moisture contents will ripple through to proven yields, APHs, to government programs like the coronavirus that took production data to calculate disaster payments. All of those will be impacted somewhat by the fact that the grain was over dry. There's not much we can do about it, but that was a factor. And putting liquid water on grain is not legal, and aerating to re-wet grain is very difficult to do and tricky to do. If you want to learn a little bit about the moisture balances, you can see our website there. There is a phone app that will estimate the amount of over-drying or re-wetting on a given day with a given conditions. It's used for grain storage checking, but that app will also tell you a little bit about how much moisture loss we might have in any given situation. This data I show every year. It's the storage time data for moisture and temperature. We probably will not have a problem this year. Moistures will be down in the lower ranges. Those are in months, so colder temperatures and lower moistures have storage times in over 12 months. I will just say over 12 months. We should not have a problem with maintaining quality of the grain in storage. That was something I feared with all of the grain laying on the ground and so forth, but the combination of crop insurance mitigation and then significant field drying kind of took that one out of the picture. However, it is still possible to have storage problems in dry grain without the proper aeration and keeping it cold. We have less mold and mycotoxin risk than we would have expected. If you're going to feed your grain, I would still test it for protein because we're probably a little on the low side. Same with distillers grains or soybean meal. Expect that your grain will break up more. Grain breaks for every 2% of moisture that you lose below about 15, you get double the fines in a handling operation. So we're going to have a lot of handling breakage. It's not much we can do about it. Handling 12, 13% moisture corn will create a lot of broken grains, and it will create dust issues. Those in the grain industry understand what dust issues mean. The fines breakage also creates uneven airflow distribution, particularly in the center. So you want to take out the center cores a little more aggressively this year than you might in a normal year. We will have more fines in there and therefore poorer aeration in the middle. Poor aeration in the middle often translates into a slide gate that gets opened and nothing comes out. That's not a pleasant situation because the fixes for that are either dangerous or difficult or both to get a bin that has essentially frozen fines in the middle to run again. That's a dangerous proposition. So we will have more fines. Pay attention to that in removing center cores as quickly as you can, and don't let them set up and get hot. Dry grain can spoil. If not aerated, moisture will move around, temperature differences will occur, and there can be spoilage. So the key there is maintain cold temperatures, seal the fans and so forth so there isn't natural convection in there. There's only convection when you want it to be. And be sure you can keep the headspace ventilation open, not snow or anything like that, because the headspace ventilation is key to carrying away condensation. If you have cold grain and you keep it cold for a long time into the spring, then headspace ventilation is critical to take out the condensation. But with a little aeration monitoring and management, plus removal of center cores and fines, we should be in pretty good shape to store this year's crop, even though it will have a higher breakage potential than normal. There are a lot more items and tips and podcasts on our website. Please visit us. There's more than just that app. Please visit the iowagrain.org website. And with that, I will conclude. I hope that this was informative. I will just sum it up by saying we dodged a bullet. It could have been a lot more difficult than it was from a grain storage perspective.